I have two examples here of rational expressions with operations. I have two rational expressions that I'll multiply and two rational expressions that I will divide. When I multiply, I factor the numerator and the denominator, looking for common factors so that I'll be able to reduce these fractions. So when I multiply fractions, you do numerator times numerator and denominator times denominator. So essentially, I could just write a big solid line here and multiply these expressions across the top and then multiply these expressions on the bottom. I'm going to rewrite this grouping like terms. So I'll put the numbers together. I have 2 times 15. 15 is 3 times 5. And I have x to the fourth, which is 4 x's multiplied together. And I have x squared, which is 2 additional x's multiplied. And I have y to the fifth. So 5 y's multiplied by each other. This is my numerator, expanded, factored. In the denominator, I have 3 times 8, which is 3 times 2 times 4. That could be factored further. And I have x squared, so 2x's multiplied, and x to the third, which is 3 x's multiplied, and then y squared. My goal is to match up the factors in the numerator and the denominator so that I can write as many ones as possible so that I can reduce my fraction. Before I reduce anything, I need to make sure that my denominator is never 0. And many times, this is easier, this is simpler if you work with this while it's factored. So before I do anything more, I need to determine which values I exclude, which is only important for the denominator. I need to make sure I never divide by 0. Dividing by 0 would happen with this rational expression if x is equal to 0, and also if y is equal to 0. So those are the two values I'll exclude. Now I can rearrange this expression by separating out the parts that would make ones. I have 2 times 3 in the numerator, that's 6. And I have 3 times 2 in the denominator, which is also 6. And I have 1, 2, 3, 4, 5, 6 x's in the numerator and 5 x's in the denominator. So I can make a group of 5 x's over 5 x's. I can also make a group with 2 y's over 2 y's. And all of these, when simplified, would be 1. These are different specific ways to write 1. Then I can write together the parts that are left, which would be 5xy to the third in the numerator and 4 in the denominator. 5xy to the third is equivalent to the original multiplication problem as long as I make sure that x is not allowed to be 0, it's excluded, and y is not allowed to be 0 either. So here's my simplified rational expression. when I have rational expressions that are divided, I'll still factor them. I'll still look for as many ones as I can compose. But when you divide, you multiply by the reciprocal. So I'll flip the second fraction upside down, and I'll change this to multiply when I do that. So my rational expression changes and becomes 2x squared minus 6x times, over x squared minus 2x minus 3 times x squared plus 3x plus 2. This becomes the numerator. X squared minus 3x minus 10 is the denominator when I multiply by the reciprocal. Now I'll factor all these with the plan of reducing these fractions. First, I will factor 2x squared minus 6x. This can be written as 2x times x minus 3. Next, I'll factor this denominator, which is x squared minus 2x minus 3. When that's factored, I get x minus 3 times x plus 1. I then can factor x squared plus 3x plus 2 as x plus 2 times x plus 1. And I'll factor x squared minus 3x minus 10 as x minus 5 times x plus 2. When I write this all together, factored, I have 2x times x minus 3 times x plus 2 times x plus 1. This is my entire numerator, factored. My denominator, when it's factored, looks like x minus 3 times x plus 1 times x minus 5 times x plus 2. And I rewrite this matching up factors in the numerator and the denominator so that I can make as many ones as possible and reduce the fraction. I have x minus 3 in the numerator and also in the denominator. So I can write that as 1. And I have x plus 1 in the numerator and the denominator. So here I have another 1. And I have x plus 2 in the numerator and the denominator. So I found another 1. And this leaves 2x over x minus 5. Before I simplify this and eliminate all of the fractions that simplify to 1, I need to make sure that my denominator is never, ever 0. So x minus 3 cannot be equal to 0. And X plus 1 cannot be equal to 0. X minus 3 is 0 when X is 3. X plus 1 is 0 when X is negative 1. Also, X minus 5 cannot be 0, which would happen if X was 5. And X plus 2 cannot be 0, which this would be true if X was negative 2. Now I can reduce my fraction. This becomes 1, this becomes 1, this becomes 1. And what I'm left with is 2x minus 5, as long as I'm sure not to allow x to be 3, negative 1, 5, or negative 2. Oh my goodness. Sorry. There.